symbol for the axiomatic definition. But there are cases also where you don't want to have constraint or predicate part. Means that you want to say there are max students in each class, but you didn't want to specify the value. Okay, you didn't want to specify the value. So what you have to do is you just use the bar here. There is a bar inside the Microsoft Word there, or inside your Z GitHub there. There's a bar for the axiomatic definition without predicate part. Okay, without predicate part. Wait, any question? Wait, I have to open. I haven't opened the Microsoft Word yet. I just want to recap whatever that we actually discussed last week. Okay, so later if I want to show you somewhere, I will open up Microsoft Word and show you. Okay, yeah? Okay. Oh, I open like this, can or not? If not, I cannot see your message. Wait, let me make it bigger. You can see, right? If I didn't do the slideshow, then normally, like that. Okay, so if I didn't do the slideshow, you can see clearly, right? Even though if I didn't do slideshow, like this. Okay. So I will not do the slideshow lah. At least I can see your message. Okay. So just now, when you do the sleeping tea just now, okay. So when you do the this part, okay, you have the constraint. Okay, means that you have the condition lah. Okay, you want to put the value. Okay, you want to put the value, then you do like this. But there are cases, for example, you want to show in terms of the, for example, capacity. Okay, let's say Dewan Kuliah capacity, for example, Dewan Kuliah capacity. So we will have different size of our lecture theatre or Dewan Kuliah. Okay, so we will have different size of lecture theatre. So one maybe can occupy 150 students. Another one maybe 200 students. Maybe another one you have 120 students only. So we have different size of Dewan Kuliah. So you don't want to put the capacity. You don't want to put the capacity. So what you do is you just do without constraint. Okay, you just put capacity, for example, capacity or quantity here of type N. So you don't need to put the value. So when you want to say maybe DK1, 120 students, or DK5, 150 students. So it will follow the DK number. Okay, the capacity will follow the DK number. So you don't have the specific value. So if you don't want to have the specific value or the specific constraint, then you go for the axiomatic definition without the predicate part. So same thing like previously, if let's say you have more than one, you should have 2 or 3 according to how many constraints that you want to have, or how many variables that you have. Okay, you cannot combine into one. Okay, with or without the constraint, you cannot combine into one. Okay, so that is actually your axiomatic definition. So axiomatic definition will be, okay, from first thing is data type, free type, then after that, axiomatic definition. So axiomatic definition is not compulsory. So it's up to your system. Okay, it's up to your system. If let's say you want to have the axiomatic definition, then you put after free type. Maybe all of you does not have any axiomatic definition at all. Then you don't have to do that in your assignment, for example. No need. Okay, because this is not this is not compulsory for you to do. You do when you want to make it general for all your team members and so on. Okay, so it means that you want to have a global variable. Okay, then you do axiomatic definition. Okay, if you don't have any global variable, then it is okay not to do axiomatic definition. Okay, so that is the thing that you have to remember lah, because axiomatic definition is not compulsory for you to do. Only you do if you have global variables that you want to put inside your assignment and so on. Okay, so this is two way to write. So what either using, I normally call as sleeping T here. So either using the sleeping T symbol, or you just use the bar symbol here. Okay, this bar is not from a normal bar from the keyboard, from the keyboard. So it's actually there is a symbol bar there where you can actually take from ZWord Tools or Z GitHub just now. Okay, so the next one is sometimes, okay, you want to have axiomatic definition as a constant. Just now like normal variable, but a constant. Let's say you want to have constant pi equals to 3.14 52 or something like that. Cannot remember the variable. So for example, you want to have a constant. Okay, same like your programming, you want to have a value constant. You can also do axiomatic definition. Okay, so you can do using sleeping T, or rather than you use this symbol, okay, you can also do after free type using double equal symbol. So define as. So if let's say you want to have pi value, okay, a constant value, you can use axiomatic definition to represent that value, or you can also use a double equal symbol. Okay, this is what we call as define as. The double equal, the meaning of double equal as define as. That is the meaning of it. Okay, so you can use either using axiomatic definition or using double equal if let's say you have a global constant, for example pi value and so on, for you to do the calculation. Okay, let's say you want to convert Celsius to Fahrenheit. There is a formula for you to do, and then there is an exact value that you want to do. So maybe you can do something like a constant and so on. But normally like pi value, those are actually, because pi value is a very long value. So you want to have inside your calculation like with 3 decimal points only, okay, or 4 decimal points only. So you don't want to put like around 16 decimal point. You don't want to use that. So you want to go for 2 decimal or 3 decimal or 4 decimal. So you want to be constant in all your system. So if you want to do that, you can use the axiomatic definition symbol, or you can use double equal symbol as defined as symbol. Okay, so this is also another way that you can do in your using your axiomatic definition inside your system. So for this constant also, because it's actually global, you put also under, or you put also under free type together with your axiomatic definition. Okay, so basic type, free type. After that will be your axiomatic definition or global constant declaration here. Okay, then after that, we are going to do another thing, what we call as Z schema. Okay, so the step is basic type, free type, and then you may have axiomatic definition or you may have a global constant. Then after that, we are going to start with Z schema. Okay, so Z schema consists of 2. Okay, consists of 2. So what you are going to do inside your Z schema, okay, first thing is, just now I said we are going to have data type, okay, and then you may have also free types and also axiomatic definition and so on. Then after that, after your all the axiomatic definition, all those things, then we are going to start our schema. Okay, we are going to start our schema. So schema or Z schema consists of what we call as small pieces of your module or operations, okay? And then inside there, you are going to have what we call as data. So this is where you are going to represent using variable declaration, and also you will have some operation inside your schema there. Okay, your constraint, your operation, and so on. So that schema, okay, is divided into two. Okay, it's divided into two. One is what we call as static schema. Another one is dynamic schema. Okay, static. Okay, what is the difference between static and dynamic? Okay, static is what we call as state space schema. Static, okay, static is actually a schema that you use to communicate with your database. Okay, so static schema, also known as state space schema, where inside this schema, the data, your variable, your constraint, whatever, will be static, means global for your part. Okay, global for your part means that whatever that you do, okay, whatever that you do is actually general for all the operation that you are going to have after that. So this static schema is used, okay, remember, is used, whatever variable that you have inside your static schema is used to communicate with your database data. Okay, your database data. So inside there, you will have your variable. You will have also some of the condition. Okay, and then you may have condition here will be the requirement. Okay, requirement, your constraint, whatever you will have inside your static schema. Okay, but the main important thing is, even though both dynamic also will have the variable and so on, but static schema is the only schema that you use to communicate with database. So in your assignment, static schema will be your module. Okay, in your assignment, static schema will be your module. So we are going to name our module, okay, as our static schema using our module name. Okay, we are going to rename our static schema or state space schema using the module name. So assuming that you have two modules, so you are going to have two static schema or two static aspect of schema system. Okay, so static schema will be the schema that you are going to use to communicate with your database data. Okay, so you will have declaration, you will have constraint, same as dynamic, but those variable that you are going to do in your declaration and those constraint is actually global for all. Okay, global for all the schema, all the operation schema that are going to use the state space schema lah. So later I will show you what I meant by that. Okay, so another one is the dynamic schema. Okay, dynamic schema, the way to write will be the same as static schema, no different. Okay, no different. There will be declaration, there will be also condition and so on. No different. Just that the dynamic schema is to show the transition. Well, what is the changes from one aspect to another aspect, the transition there. There will be post-condition, there will be precondition and so on. What happened after that? So from before and then change and then what happened after that. So it will show the transition of your data, okay, from maybe let's say you want to add customer. First thing is the customer does not exist in your database. Then after that, you add the customer, and then the customer now, the data of the customer will exist in your database. So the transition from without not exist into exist will be dynamic aspect or dynamic schema. So normally for dynamic schema, you will use in your operation schema. The operation schema will be the one that for your assignment, I ask you to choose 3 operations. These are actually where we are going to show our dynamic schema, dynamic aspect of your schema. Okay, so there are 2 aspects of your Z schema. One is static, one is dynamic. So static normally will be state space schema. So normally you are going to represent using state, using your module name, using your module as the state space schema. Whereas for the dynamic aspect, Okay, this is actually following your operations. The one inside your assignment, I asked you to use or to choose 3 operations. So we are going to show dynamic aspect through our operation schema. Okay, so we are going to show pre, post condition and so on. The transition, okay, the changes, the transition. There are also some relationship maybe you want to do, remember. For example, forms, you have optional area or optional part of the forms that either the customer will key in or not key in, is up to them, optional. So this also will be a part that you are going to show inside your dynamic aspect. Okay, for example, you use set comprehension, you use a quantifier there exists for all those things you are going to show in your dynamic aspect of your Z schema. Okay, so later I will show you using Microsoft Word what is the difference between static aspect and dynamic aspect. Okay, so when we start our Z schema, because you are going to have dynamic aspect and also what a static aspect. So what are actually the steps? Okay, so just now after axiomatic definition, I said Z schema. So what are Z schema consist of? Okay, the first one, okay, the first Z schema that you have to write after your axiomatic definition, for example, after your axiomatic definition is your state space schema. That is the first one. So state space schema is your static aspect Z schema. So the first one that you are going to start off your Z schema is what we call as state space schema. Okay, so after you have written your state space schema, then you are going to do what we call as initial state schema. Okay, initial state schema. So initial state one time only. State space also one time only. Okay, so you have state space schema. The second step is initial state schema. So initial state also we say as static aspect because no changes. Okay, we just initialize the value, no changes to it. So it is also one part of static aspect. Okay, one part of static aspect. So you just do once initial state. Okay, so for this part, number 1 and number 2 here, these are actually comes from static aspect of your Z schema. Okay, but the most popular, I will say as this one. Okay, because this is the one that will actually really communicate with your database. Whatever variable that you are going to put inside your state space schema will be used to communicate with the database. This one is just the starting to initialize your variable. That's all. Okay, initialize your variable and so on. That's all. Then it is also static aspect, but not really communicate with your database. Okay, one time only communicate. That's all. Then after that, you are not going to use the initial state anymore. Okay, so after your initial state, the next one will be what we call as operation schema. Okay, we call as operation schema. So operation schema here will be the dynamic aspect of your Z schema. Okay, so operation schema. So these are general. Okay, it means that for a whole Z schema, okay, you must have these 3. You must have these 3 when you start with your Z schema. So state space schema as the static aspect, you have your initialization, and then after that you have operation schema. Okay, after operation schema, okay, the next step, okay, is actually for improvement of your system, to refine your system, to make it better. So you add another what we call as error scenarios schema. So that is after operation schema. But the main or the major thing about your Z schema will be these 3. Okay, because when you want to show what happened inside your system, you need to show, okay, the static aspect and also the dynamic aspect. So dynamic aspect is your operation. When you want to do error scenarios and so on, that one is for improvement of your system. Let's say you want to add the customer, but the customer is already exists. So what happened? So that is actually to show error. But if the customer does not exist, so we are not going to call error scenarios at all. Okay, so error scenario will just do later for what we call as refinement of your Z schema. Okay, yeah. So the main Z schema consists of these three parts. Okay, yeah. So for all these state space schema or initial state or operation schema and so on, we are going to have three structure or elements inside that. Okay, we are going to have three structure of that. So we are going to have declaration part, we are going to have some expressions, and then we have also some constraints that we want to put inside our Z schema. Okay, we are going to have three elements. So you can have declaration part, you can have also expression. This expression can be a formula, can be your assigning value, and so on. And also some constraint that you want to put inside that. Okay, so constraint, for example, precondition, post-condition, and so on. So you are going to have that inside your Z schema there. Okay, so these are the three elements that mostly you have to remember. So for these three, okay, where or how you are going to put that. So Z schema, okay, I will show you the symbol letter for Z schema consists of three parts. Okay, of course, remember, you are going to have a schema name. Okay, and then you have the declaration. This is where you put all your variable declarations and the predicate part. Okay, inside the predicate part is where you put expressions and predicate here. So declaration, you put inside the declaration part. Expressions and constraints, you put inside the predicate part. Okay, so when you talk about Z schema, you have declaration part and predicate part. These are another name. Signature part or logical part is another name that when you read maybe other books or other reference, they will use signature part and logical part. So you should know, okay, what is actually represent. So declaration or another name will be signature part, whereas predicate, another name will be logical part. So your declaration just now will be inside the declaration part, whereas for the expression and also for the constraints will be inside the predicate part. Okay, so this is actually Z schema. So how you show that using your graphical notation. Okay, so Z schema can be displayed using two notation, but the one that we are going to use a lot will be graphical notation. Okay, text form will be used also later, especially to show the complete schema. Okay, so for the time being, we are not going to use text form format. Okay, we are going to use graphical format. Okay, so graphical format, okay, the symbol is this one. So just now you see divided into three parts. You have schema name, you have declaration, and predicate part. So in your graphical format here, okay, you have those three parts. The schema name, okay, declarations, and also the predicate part. If let's say you use GitHub, so this, the schema name, declaration, and predicate will not be italic. You don't have to worry. Okay, when you use Microsoft Word, it will be italic. So it's not a problem, whether italic or not italic, it's not a problem. Okay, so don't worry if you use that GitHub, it's not italic, but your friends use Z02 is in italic version, so you don't have to worry. Okay, it's not a problem whether italic or not italic, bold or not bold, is not a problem. Okay, just to let you know that you have to remember there are three parts. Okay, so you have the name of the schema, you have the declaration part, and you have the predicate part. Declaration part will be for all the declaration, whereas the predicate part will be just now expressions and also the constraints inside your system. Okay, so in your static and dynamic aspect, we are going to use the same symbol. Okay, so you don't have to worry whether a static aspect must be different symbol, dynamic aspect must be different symbol. No, we are going to use the same graphical format for both static aspect and also dynamic aspect. So you don't have to worry. Just remember that, okay, the graphical form, okay, will be, you have the schema name, you have the declaration part, and you have the predicate part. Either for static or dynamic, it will follow the same symbol or the same graphical format. So you don't have to worry which symbol to use for static, which symbol to use for dynamic. No need. It will be the same symbol. Okay. So for the schema name here, okay, for the schema name here, if you remember last week during tutorial, there are actually one question asking you how to do the schema name. Okay, so a schema name always starts with capital letter. Okay, when you have one word, for example, okay, so that word must start with a capital letter. The rest of the word will be in small letters. Okay, so remember, if it is a one word name only, okay, so the first character must be capital letter. The rest of the characters, okay, will be in small letters. Okay, so if let's say you have more than one word, two, three words that you use, okay, so every word must start with a capital letter. And then you cannot have space in between those words. So all these words, let's say you have three words, okay, you combine as one. So each word must start with a capital letter, okay, and then other words, okay, must be in small letter. So you have to combine these three words together into one. Okay, no space, no underscore, no digit, no symbols are allowed inside or to have as your schema name, to be put as your schema name. So you cannot have digit, you cannot have underscore, you cannot have space, you cannot have symbol inside your schema name. Okay, so for the schema name, okay, for example, I have two words here. Okay, I have two words here. So two words, each word must start with a capital letter. So add A capital letter, C also capital letter. The rest of the word, the rest of the characters will be in small letters. Same thing if you use one word, C must be capital letter. So as I just now, we cannot have digit, we cannot have all capital letter, we cannot have underscore, we cannot have symbol, we cannot have space also. The space I didn't put. So if you want to have, you can have like this, also an error. So schema name cannot have space, cannot have symbols, and so on. Okay, so that's why when you see the symbol just now, okay, you see that the way that they put the schema name here shows how you need to actually do for your schema already. So you have two words, each word start with capital letter. No space, you see no space, and no symbol, no digit is allowed here. So that is actually how you do the schema name. Okay, how you do the schema name. So we are going to use this graphical format a lot later during our schema name. Okay, so in the declaration just now, okay, you have the schema name, then you have declaration, and you have the predicate. So in the declaration or signature part of your schema, okay, so you are going to declare your variable. Okay, you are going to declare your variable using your identifiers and type and so on. So the syntax, okay, the syntax of your declaration part, okay, each line after you wrote a single line there, each line is assumed to be terminated with semicolon. So you don't need to put semicolon like programming. You have to put semicolon. This one, you don't need to put semicolon, but it is there. Okay, it is there inside your declaration part. So you don't have to put semicolon, but it is assumed to have semicolon at the end of the statement. Okay, so that's why when you do variable declaration, make sure that one single line. Don't combine declaration into, let's say, two declaration inside the same line. Don't combine. Make it separately. One line, one line, one line. Okay, so because it will assume that at the end of the statement have a semicolon. So if you combine two